For our problem, we have gaseous ethane reacts with oxygen gas to produce gaseous carbon dioxide and water. Now, ethane, the formula for ethane is C2H6. And it reacts with oxygen gas, so plus O2, and it produces carbon dioxide, CO2, and water, H2O. Now we need to balance this equation. So if we have 2 molecules of ethane on this side and 7 molecules of oxygen on this side, that would mean that we need 4 molecules of CO2, so we have 2 times 2 is 4, so that balances the carbons. We need, oh, I forgot, there's 6 H2O, right, okay. We need 4 times 2 is 8, and then 6 times 1 is 6, so we have
8 plus 6 equals 14.
We have 14
7 times
oxygens,
2. Yep.
7 times 2 oxygens,
Yep.
so the oxygens are balanced. We have 6 times 2 hydrogens, 12 hydrogens, 2 times 6, 12 hydrogens.
Alright.
So that is our balanced equation.
Yep. So for number A, it says, suppose a chemist mixes 13.8 gram of ethane and 45.8 gram of dioxygen. Calculate the theoretical yield of water. So in order to get the theoretical yield, we first need to calculate the molar mass of each element, molecules. So molar mass of ethane is equals 30.07 gram per mole. We use the periodic table for our reference, by the way. And O2 molar mass equals 32.00 gram per mole. And then we need to calculate the grams into the mole of each molecules. So the given number is 13.8 gram of ethane, which is C2H6, times the molar mass is 1 mole over 30.07 gram, and this equals 0.405 mole of ethane, which is C2H6. And then we need to get the O2 molar mass, which is 45.8 gram O2 times 1 mole over 32 times O equals 1.43 mole O2. And then if you see these numbers, you might think ethane is the limited reactant, but it is not true because we have to multiply these numbers by the molar ratio, and if we do that, it gives us times divided by 2 equals 0.230, and divided by 7 equals 0.204. So the oxygen has actually smaller amount of mole, and then that means limiting the oxygen is limiting reagent. And then now, what we have to do is multiply this number by 6 mole H2O over 7 mole O2. And then, once again, we need to multiply this in 18.02 gram per 1 mole H2O, and that gives us 22.1 gram H2O for our theoretical yield, which means our oxygen get used up everything. There will be 22.1 gram of H2O. Yep. And then Timothy, you want to do the percent yield of water? Yep.
So we say, suppose the reaction actually produces instead produces 14.2 grams of H2O. Calculate the percent yield of water. Now the percent yield, the percent yield is the actual yield that we get, which is 14.2 divided by our theoretical yield, which is 22.1. If we divide that
Times 100. Times 100.
well,
Yeah.
times 100 to get into a percent, that equals 64% yield of water.
And lastly, this reaction is combustion because it occurs between a fuel, which is ethane, and oxidizing agent, which is O2, the oxygen itself. Thank you for watching.